Welcome, my dear students, in our second lesson in Unit 1, which is flowcharts. Today, we will learn something new, a new concept, which is flowchart. In the previous lesson, we learned about the problem and the problem-solving stages, which are problem definition, and we learned that we define three things about our problem: output, input, and the solution steps or the solution operation. Then we perform algorithm. Algorithm is a group of logically ordered steps to reach our goal or to reach the solution of the problem. And we said that we represent the algorithm or represent these steps by a diagram called flowchart. Program design. In the program design, we translate the flowchart to the computer by using a programming language. Program testing. We test the program to check for errors, to make sure that the program is free from errors. Program documentation. In the program documentation step, we write or type all the inputs, the outputs, the flowchart, the programming languages, the last date of modification for the program, who are the persons who shared in the program, all what I did to solve the problem. And we said that this is a very important step for feedback and when more than one person participate in the same program. Flowchart. What is a flowchart? A flowchart is a diagram that uses standard geometric shapes to represent the steps for solving a problem or specific question. What are the advantages of flowcharts, or why we use a flowchart? The flowchart tells the programmer what he should do, makes it easy to explain the program for others, and it's an important documentation tool. Let's see the types of flowcharts. We have three types of flowcharts: simple, branching, and looping. The simple flowchart form. The form of simple flowchart is start, input, process, output, end. And as I said last time, to differentiate between the input and output, we use some words with the input and we use other words with the output. With the input, we use input, enter, get, read. With the output, we use output or print. Of course, the process is simple for any division, multiplication, average, product, sum. Any calculation will be put in the process. Let's see an example. Our first example. Draw a flowchart for a program that will calculate the sum of two numbers entered by the user and display the result. I want to make a program that will calculate a sum of two entered numbers and print the result. First, I should define my problem. What I should define about my problem? Three things: the output, the input, and the solution steps. Here, the output is the sum of two numbers. I want to calculate the sum of two numbers. So this is my goal. The input, I want the sum of two numbers. So I must enter two numbers. And we said we use variables in drawing of the flowchart. So the first number will be A and the second number will be B. The solution steps. C equals A plus B, where C is the result or the sum. This is the algorithm. Of course, I start the program, then I enter or input the numbers A and B, then calculate the sum of these two numbers, and display print sum means display the result or display the sum. End. Let's draw our flowchart now. Start, enter B, C equals A plus B, print C, end. The second example, draw a flowchart for a program that will compute the average and product of three numbers. First thing, I should define my problem. The output, here we have two outputs, the average and the product. So I want two things, not one, the average and the product of three numbers. The three numbers are x, y, and z. Solution, average equal x plus y plus z divided 3, the product x times y times z. And please notice that the divided in the programming language is written as a slash and the multiplication is written as a star. This is the algorithm and this is the flowchart. Start, and the input, read x, y, and z. The process or the calculation, I'll calculate the average and the product. Then print average product and the program. These are examples for the simple flowchart. Second, we will talk about the branching flowchart or the use of branching or the decision in flowchart. There are many problems that contain a question that requires a yes or no, true or false, and depending on the answer, branching is done. I use branching also when I compare, when I have a comparison. Let's see what are the comparison operators. The comparison operators are bigger than or equal, smaller than or equal, equal, and not equal. When I have these in the problem, I use the branching. First example, draw a flowchart to print the word successful in case of the degree input is greater than or equal 50. I want to design a flowchart for a program. This program will obtain, for example, the marks of the students, and if the mark of the students is bigger than or 50, it will print or display the word successful. First, define the problem. The output will print the word successful. The input will be the mark or the degree, which is X. The solution, If x or the mark is bigger than or equal 50, print the word successful. And this is the algorithm and the flowchart of this problem. Second example, draw a flowchart for a program that obtains a number from the user and determine the number type, even or odd, and print the result. I want to design a program or a flowchart for a program that will obtain a number from the user. When the user enters this number, the program will display either the number is even or odd. Of course, the even numbers are the numbers that are divisible by 2 without a remainder. First, I define my problem. The output is to print the number type even or odd. The input is the number, which is n. The solution, if the number entered is divisible by 2 without a remainder, then print even, else print odd. And this is the algorithm and the flowchart of this problem. By this example, we come to the end of our lesson for today. Hope you understood our lesson, and see you in next lessons and more examples about branching flowcharts.